Now, if we had to install Docker, how would we do that? So that part won't be hands-on because we already have Docker installed. But I wanted to give you an idea of, okay, if we wanted to install Docker, how would we do? Um, so I'm going to do an arbitrary distinction between three scenarios. Either I want to install Docker on a Linux machine. Maybe it's my desktop Linux machine. Maybe it's some VM or some physical machine I have somewhere, but it's one Linux machine. The second scenario is when I want to install Docker on a Mac or on a Windows machine. And the third scenario is when I have a fleet of servers, or typically cloud VMs, and I want to install Docker there. So it's not just a one-shot install, but it's like, hey, I have 1,000 nodes and I want to install Docker there. How should I do that? So first, when you want to install Docker on a single Linux machine, the easiest way is to install the packages supplied by Docker Inc. And here I wish I could like highlight this and make, like resurrect the blink tag. So why am I insisting that we use packages from Docker Inc? It's just because distros move slowly, and I'm not saying that in a bad way. Linux distros are extremely stable, and that's a good thing. And that means that once a package gets into a distro, you're not allowed to have a major update in that distro release. It means, for instance, if I'm installing, I'm going to just pick something random like Fedora 22 or Debian 8, and I install Apache and I get Apache 2.2. Then if there is an Apache 2.3 release, it's not going to get in. I'm going to have like 2.2 point something. I'm going to have security fixes, bug fixes. But if there is a new awesome feature in Apache 2.3, I'm not going to get that in my Fedora or Debian release. I will have to wait for the next release. That's good from a stability point of view because honestly, when you run on servers, it means that you can almost blindly run dist upgrades. Well, precisely not dist upgrades, but upgrades. You can update your packages and you know that you're going to get the security fixes, but that you won't break a random service because a new feature came in and it's incompatible with what you're choosing, etc., etc. So that's good. But for something like Docker, which when it started 4 years ago now, there was one release every month. Now we still have one release every month, but they are much smaller releases. But we still have like average size release every 3 months. That means that if you get your favorite distro and you install Docker, you're going to get a version of Docker that is relatively old. And that's sad because there are many really cool features of Docker that have been added recently. And so if you like, it's even frustrating in some ways because I realized recently if you go to Google Compute Engine and you say, oh, I want to spin up a VM and I want to do Docker stuff with it, the versions of Docker that they propose are more than 1 year old. And I'm like, what? So for this reason, I kind of insist, use the packages that are provided by Docker Inc. because that will make a huge difference in stability, features, etc., etc. But the general idea will be to enable Docker's package repos and then install that. I'm not going to dive into the specifics because it's slightly different for each distro, and it's a little bit more complicated than just doing yum install Docker or apt-get install Docker, but it's still something you can do easily in 5 minutes, and it's clean. It's clean in the sense that it's going to add an external repo to your package list and install from that. So it's not like some dirty shell script that you download and run and pray that it works. And if you are using a distro that is not supported for some reason, I can't remember which distros are supported or not, but even Arch Linux, which could be considered as a kind of not a major distro, is supported. So but even if you use a distro that's not supported, then there are also binary builds that are available, so that you can install that easily. Okay, that's for the Linux scenario. Now, if you have a Mac or Windows machine, on a Mac there is something called Docker for Mac, which is, I will say, pretty awesome because you install that as a normal application So like you drag the thing to the applications folder and that's it. And then it gives you Docker as if you had Docker on a native Linux environment. If you're using recent version of Windows, and that's the exact versions, I'm not really a Windows person, so I honestly have no idea how recent that is in the Windows landscape, but if you're using these versions of Windows, you're covered. There is Docker for Windows and also pretty great. If you have older versions of Windows, then there is something called the Docker Toolbox, where the experience is not as nice and polished and everything, but it's still pretty close. So here I'm going to explain a little bit the architecture of the Docker engine itself. The first command that I run here, Docker version, you see it has two identical, well, nearly identical outputs. There is client and server. Each time we run a Docker command, we are in fact making an API call to a remote server. Well, in that case, the remote server is not really remote. It's on the same machine, but I'm still making an API call to that server. It's a little bit as if I was doing like curl localhost. So when I do Docker version, first it shows me the version of the CLI, and then, so like that's like 17, 11, blah, blah, blah. And then it shows me the version of the remote server that it did connect to. And you can see that it's almost the same thing. Like you can see it's the same git commit, so it was built from the same source code. But if you look at the build date, it has like 1 minute and 30-second difference, just because those are different binaries. And so during the build process, they were built like within a 2 minutes interval. So each command, when we will run containers, list containers, etc., each command will be an API call. So that's great because it means that when we need to talk to a remote Docker machine from our local environment, we can do that. We can set a variable to say, hey, I want you to talk to this Docker engine there, and it just works out of the box. And when you run on a Mac or a Windows machine, it means that the CLI is going to run locally, so it's going to be a Darwin binary or a Windows executable, and you will talk to a remote Docker engine, which is in fact a Linux thing running in a tiny VM on your machine. So if you're using the Docker toolbox, that tiny Linux VM is not really hidden, it's just running inside VirtualBox. So if you fire up VirtualBox, you will see, oh, there is a Docker VM here. If you're using Docker for Mac or Docker for Windows, it's using some slightly more advanced things. The bottom line is that it's a VM, but where many components that are not necessary have been removed so that it's lighter, faster, and doesn't have the typical downsides of VMs. Okay. Docker for Mac and Docker for Windows, great. One important thing about security when you run Docker on Linux machines, once you can run containers, those containers can do many things. Maybe I won't do that demo, but we could easily come up with a Docker run command that would give way too many permissions to that container. Like that container would be able to access the host environment, etc., etc. This is by design because Docker lets you run containers that will be able to assume some system functions. So typical examples, if you have physical machines with SCSI or fiber channel adapters, you could run the management software for those adapters in a container. Or you could even run an hypervisor in a container, which at first sounds weird. Like okay, so I heard people are running containers in VMs, but now you're telling me that you can run VMs in containers. Why would anyone do that? Well, beyond I'm on my machine, I have a VM that runs the containers that runs a VM scenario. Some people are actually running VMs in containers. For instance, each time you spin up a VM on Google Cloud, that VM is in fact in a container, not a Docker container, but a container using resource limitation mechanisms like cgroups, etc. So that's a valid use case. So when I have the permission to start a container, I can give that container many privileges and many rights on my machine. So that means that if I give Docker access to somebody on my system, it's just like giving them root access. So it's something to keep in mind in the scenario where you have Linux environments that are multi-user, or if you're like, oh, I'm not giving root access to my developers, but I give them Docker access, then you should think twice, because by giving them Docker access, you are giving them root access. There are ways to control that, but I'm just talking about the default scenario here. Okay.